Welcome back. Continuing on from the last video, the rule of 3. If you haven't seen that first, go watch it. We're going to talk about rule of 5 and why you would want to use this. We're just going to read it. This is still from the same site as last time, ing.cvpref. Because the presence of user-defined or equals default or equals delete declared destructor, copy constructor, or copy assignment. So notice that this is all the stuff from the rule of 3. If you're using the rule of 3, you might want to be following the rule of 5 too. So observe, because if you're declaring a destructor, copy constructor, or copy assignment operator, it's going to prevent implicit definition of move constructors and move assignment operators. So if you want move constructors and move assignment operators, you must follow the rule of 5 because, just I guess declaring these is what breaks that. All right, so any class for which move semantics are desirable has to declare all 5 special member functions. And, well, the first 3 we've already went over in the rule of 3. So these other 2, we just need to add if you want to follow the rule of 5. Now, of course, you want to ask the question, do I need these? Do I want move constructors and move assignment operators? Totally depends on your software and your program and what you're doing. But if you want your class to take ownership of memory, then the answer is probably yes, because that's essentially what the move is going to do. Is it's going to say it's going to move the memory into this class. Well, you can think of it that way. It's not exactly what it does. That's how I think of it. All right, so let's just run through this. Here's a new class. They're calling their class rule of 5. They've got the same data type as last time, just a char star. They call cstring. That's the private piece of data. Now, they did make one improvement here. You know, in the last one we went over, they had a constructor that then called another private constructor. In this one, they've just made it all public, but it essentially does the same thing as the rule of 3 one. You see, when you instantiate rule of 5, if you want, pass in the data right away, and it's going to set that all up, and this sets it up with the mem copy. So this is doing a deep copy of whatever you're passing. And then we've got the same deleter. So essentially, these are still the same as the rule of 3 so far. This one as well, same as the rule of 3, but here's where we add something new, a move constructor. So this is what you would need to add. As you can see, it's no longer const. This constructor is no longer const like the copy one was, and it's a double reference, and it's other. So the double reference is what really tells it it's allowed to move. All right, and they also have no exceptions allowed. Okay, that's fine, cool. Allows for more optimizations. Yeah, obviously you probably already know this, but the move is a very efficient operation. It doesn't have to allocate it. It doesn't have to copy data. It's kind of like a construct in place. It's like the data is already here. Just point the variable to it. It's now your variable. Move into place. So here's all they do. They call their cstring, their data type, and they instantiate it with standard exchange. We haven't talked about exchange. I'll talk about it real quick, basically what it does. So exchange is going to take the first argument and return its original value. So cstring is going to end up becoming this original value. And it's going to take that original space and turn it into null pointer. So it's going to give you this other .cstring and then set it to null pointer, basically, with just an exchange. Kind of a weird way to do it, but it works fine, especially if you want to, no one has control over this piece of data anymore that you're moving in theory anyway, other than your rule of 5 class. So setting it to null pointer after you do it is fine. And you can go look at this function if you want. You can just click on it here actually, and they've got some pretty decent data. So we'll just quickly talk about exchange, but it's let's see here. Yeah, here it is. Here's the meat and potatoes basically. So it makes the type of your old value and use standard move on object. So this is the passed in object. And then the other thing is a new value. So then it sets your object, the old one, to whatever new value via forward, and then it returns the old value. So that's the implementation basically of exchange. So basically it's just going to return this first argument with a move, and then okay, let's move on. But yeah, that's new. That's hope that makes sense. If not, study it. It's important to understand that if you're a C++ programmer. All right, rule of 5 operator. Okay, copy assignment. This is the same as the rule of 3 one, basically, for their equals operator. But if you want to also be able to move and not just copy, you gotta make your own, and it's this one here. We still return the class by reference, still an equal operator, of course, but now no more const, and we add double reference, and once again, no except for this move. Here they're using swap, and a swap kind of does what you think it does, maybe a little differently than you think. But essentially, it's going to use the move operation and move this other string, the one they passed in here, into this one. And you can go look at the definition of swap if you want, but there's also a lot of overloads. But essentially, it just does a move operation. Let's see, where is it here? I don't really show the implementation. It's mostly, I don't know, I guess I could go look at it in a header, but I'm not going to go through all that. It basically just switches these types, I believe, or switches the data they're instantiating. All right, and then it just returns the class as required. So pretty standard there, but once again, swap is going to use the move operation, especially if its signature is correct. And that's really all you need to know. So just get those move semantics in with that rule of 5. All right, well, that's going to do it for this video. Maybe, let me see if I could just cover rule of 0. Yeah, I think I'm just going to tack rule of 0 onto this because I don't think it's quite big enough to be long enough for its own video anyway. We got most of the boilerplate out with the first episode, the rule of 3, and then rule of 5 I think is pretty straightforward, just adding those 2 move assignment things. And then rule of 0, well, let's just read it. All right, that's going to be best. Classes that have custom destructors, copy/move constructors, copy/move assignment operators should deal exclusively with ownership, which follows the single responsibility principle. Let's not get sidetracked into that too much, but basically things need to manage their memory and your program's stuff correctly. That's all that really means. Okay, other classes should not have to deal with custom destructors, copy/move constructors, or copy move assignment operators. So basically what we're saying here is only your classes that handle these special case instantiating and resource acquisition and stuff like that, those are the ones that should have all this custom stuff. All the other ones should just be default. So that's basically what it means, is don't do it if you don't have to. This rule also appears in the C++ core guidelines as if you can avoid defining default operations, do. And they've got a little example here, and I'm not sure what this is supposed to show. Let's have a look. Okay, this really isn't much. It's just a single copy constructor. So I didn't mean to click on that. It's just a single copy constructor for their data piece, which they've now decided should be a string in this article rather than a char star, but okay. Okay, let's read on. When a base class is intended for polymorphic use, its destructor may have been declared virtual, public and virtual, as you've seen we've done on a lot of these episodes. This blocks implicit moves and depreciates implicit copies. And so the special member functions have to be declared as defaulted. So little changes here if you're doing polymorphic stuff. So if the destructor was declared public and virtual, it's going to block moves. So special member functions have to be declared as defaulted. Now, what's the problem with this? Well, however, this makes the class prone to slicing, which is why polymorphic classes often define copy as deleted, which leads to the following generic wording for the rule of 5. If you define or delete any default operation, define or delete them all. Now, notice that this is specific to default operations. So that may have already sank in, but just in case it hasn't, I'll say it here in the finale. This right here is not a default operation. So we're not defining any default operations. This is fine with the rule of 0. The default operation would be like an empty constructor, the one that takes nothing. That would be one of the default ones. So that's why I think I'm understanding this correctly, because this is a copy constructor, but it's not one of the default ones. Now this one, these other ones, like this one from the rule of 5, this is a default because of this equals. Like you can call rule of 5 and initialize it with nothing, and that's legal. So that's why this is a default one, is because you can call this with nothing. You cannot call this one with nothing. This needs an equals something on it to be able to be called with no arguments. So just the way C++ works. And same with up here, they are declaring one of the default ones. So I think I'm understanding that correctly. If you have information otherwise, always feel free to leave a comment. Some of the stuff gets complicated, and sometimes I say things a little out of order or wrong, just wrong sometimes. So I appreciate corrections, of course. if they are needed. All right, well, that's going to do it for this episode and this little series about the rule of 3, 5, and 0. Hopefully this helps you in your coding in one way or another. And yeah, just want to say I appreciate you guys. Thanks for watching and for any and all support. It means a lot. Peace out.